Okay, wonderful class. We're going to learn about configuration of stereocenters. In other words, the R and S when you label things R or S, and how to know when to do which. This situation only arises when you have a carbon with 4 different things on it. So for example, this carbon right here has 1, 2, 3, 4 different things on it. Okay. I'm looking for colored pencils. Okay, cool. I got some. So, the first thing you want to do is assign priority to things. The simplest way to assign priority is you're always going to look for the thing with the highest atomic number. That's going to get a number 1. If it's got the highest atomic number, it's number 1. If it's got the lowest atomic number, it's number 4. So looking at the periodic table here, hopefully you agree we have bromine. Over here, don't forget this is a carbon with 3 hydrogens on it, right? Here we have a hydrogen and a fluorine. So all you do is you look to the very next thing. So this carbon is attached to a hydrogen, a fluorine, a bromine, and a carbon. Let's just look and see which one has the highest atomic number. The atomic number is like the number on top here. So 1, 2, 3, 4, 5, 6, 7, etc. Hopefully you agree bromine down here is the highest. That's our number 1. Then fluorine is higher than carbon, so fluorine gets number 2. Carbon is higher than oxygen, so carbon gets a number 3. And last but not least, hydrogen, which is number 4. Okay? So that's kind of how you assign when you're given various elements. Okay, so all we're doing right now is learning priorities. So that's how you do the first one. The next is if you have some things that happen to be the same. So in this situation, we have this bromine here. And we happen to have 2 carbons, right? So then you go to the next thing. So in this situation, your bromine would definitely take the 1. Now we're looking at these 2 carbons. There's a difference between these 2 carbons. There has to be because I told you this is a stereogenic center. There's 4 different things on it. This carbon is attached to just hydrogens, but this carbon is attached to another carbon, right? And because of that, this has more stuff on it, if that makes sense. And that's going to be our number 2. Then we have this number 3 over here, which was just a carbon. And then last but not least, number 4, because we know the atomic number of hydrogen is very small. All right, sometimes you have double bonds. If you have a double bond, that counts as 2 things. A triple bond would count as 3 things. So here again, we have a bromine, that's going to be our number 1. But now we're looking at this carbon and this carbon. Both of them are bonded to another carbon, right? But the way I'd look at this is this one right here is a carbon with 1 carbon, and this one, even though it only has 1 carbon, it's got 2 carbon bonds. So it counts as though it were 2 carbons when it comes to priority. So this would be our number 2, this would be our number 3, and once again, the hydrogen's number 4. All right, so that's generally how you assign priority, and we'll do several examples to get us used to it, including some ones that are a little more difficult. But for now, those are pretty much the 3 examples you're running to. Once you've assigned priority, you're already set. Essentially what you want to do is look to see if the lowest priority thing, aka your number 4, is in the back. So is 4 in the back, aka on a dash? If it is, then we're golden. We're good. All you need to do is think about between 1, 2, and 3, which direction it would go if you were drawing a circle around it. So 1, 2, 3 would be like boom, boom, boom. And I hope you agree that this would be counterclockwise. So in this case, this is counterclockwise. If it were clockwise, it would be an R configuration. But if it's counterclockwise, it's an S configuration. Because this is counterclockwise, this is S. Again, this only happens if 4 is on a dash. Okay, so keep that in mind. All of these situations, 4 is in a dash, so we'll run into this a lot. So in this next one, going priority, we have 1, 2, 3. So we're going 1, 2 to 2, 3 to 3, kind of draw a circle around it. This again is counterclockwise. H is on a dash, our low priority is on a dash, so this is going to be S again. And same thing with this one, because I did a really bad job designing this. I thought I was doing so well. 1 to 2, 2 to 3. Okay, so we're going like this. So when we're going like this, hopefully you agree, this is again counterclockwise, and this one would also be an S. So after you assign your priorities, assuming that the low priority thing is in the back on a dash, you can follow this and it'll work every time. If the circle happened to go the opposite direction, it would have been an R. Let's do another example when that is not the case. In all those cases, the priority was in the back. Here, we're not so lucky. So the first thing we're going to do is assign priorities to each thing. So hopefully you agree, the bromine here is the highest priority because it has the highest atomic number. Followed by, here you have 2 carbons, right? Here and here, so they have the same atomic number, but this one has 1 extra carbon, so that's going to be our number 2. This one's our number 3, and hydrogen's number 4. So notice, in this case, hydrogen is not in the back. It's on a wedge. Anytime it's on a wedge, it's kind of like a shortcut method. You can do your normal thing, R and S, you figure out the circle, and then your answer is going to be the opposite of whatever it was. So for example, we're going to go 1 to 2, 2 to 3, 3 to 1, like this, do a little circle. And we are right now going S, right? We're doing counterclockwise. So if you're going counterclockwise, it's not going to be S. You're going to reverse it and make it R, because again, the low priority was on a wedge coming out at you, is in the front, is how they often say it too. Okay, so this was an R configuration. Let's do the same here. This again, let's take our time here. That doesn't erase because that wasn't an erasable pen. I'm used to erasable pens. Okay, let's take our time here. I almost went and put a 1 right here because I saw the bromine, but this is our chiral center, right? So from our chiral center, you want to look at each individual thing. You don't want to go all the way out, just only what it's attached to. So that carbon is attached to this fluorine, this methyl group, this hydrogen, and this carbon right here, okay? And you figure out priority from that. The thing that has the highest priority there is actually the fluorine. Followed by, here you have a carbon and another carbon, that's when you got to go to the next thing. So this is our 1, this would be our 2 right here because this is a carbon attached to a bromine, and this is a carbon just attached to hydrogens. That's our 1, that's our 2, this is our 3, that's our 4. So make sure you understand priority like that. Once again, the hydrogens, the low priority, the number 4, is on a wedge. So whatever we figure out, we're going to do the opposite of. So if we go 1 to 2, 2 to 3, 3 to 4, right now I'm going clockwise, right? So you want to say it's an R, but because it's on a wedge, it's an S. Okay. All right, let's make it a little bit harder. So here in this situation, we've got the chiral centers right here as our stereogenic center. We have 4 things. They all happen to be carbons. Cool. So there's no priority yet that we can assign. From there, you go to the next thing. That would be this one, these carbons, that carbon, and that carbon. These all are attached to a carbon, but this is attached to an oxygen. Again, the highest atomic number takes priority. This one right here is number 1. Okay. From there, you're in an interesting situation because you're looking at all these carbons here, here, and here, and you're asking, what's next? Well, this one was attached to an oxygen. This one is attached to 1 carbon. This one was attached to 1 carbon. That was attached to 3 carbons. This one takes the second priority because there were 3 carbons there. Now we're over here. Here we have 2 carbons. The purple was attached to this red carbon. So purple, red, purple, red. They're each carbons. But this one is attached to 1 carbon. And although this one is attached to 1 carbon, we count it as 2 because you have the double bond. Therefore, this is priority 3. And that sucker's 4. Okay. Our low priority is on a wedge. Okay. Low is on a wedge. All of these situations, low is on a wedge. So all you do is go 1, 2, 3. And figure out the direction it's going, then take the opposite. Hopefully you agree if it's going this direction, that's counterclockwise. So we take the opposite which would be R. Cool. Okay. So what happens if maybe it's in the plane, the low priority is in a plane, and it's not on a wedge or a dash? If that's the situation, you just go ahead and cry. But once you're done crying, you pick yourself up and get back to work. So really what you do is just find any two groups that you want to, and you switch them to get the fourth priority on a dash. Whatever you need to do to get the fourth priority on a dash. Usually you're switching one thing with the fourth thing, like this, and then I'll show you what that looks like. Okay. So here, let's go ahead and assign priority to this sucker. So hopefully you agree. We've got a bromine, which is number 1. Chlorine's number 2, because its atomic number is higher than carbon's, which is number 3, and number 4. Okay. So what you're going to do is you want to make sure that you put the fourth thing on a dash. Okay, you want the fourth thing to be in the back. So to get this fourth thing to be in the back, I take the fourth thing and I switch it with whatever was on the back. This dash one right here, this chlorine. So essentially I'm like, just kidding, this isn't number 2, this is now number 4, and that's number 2. Then you can do your normal thing, and you're just going to take the opposite of whatever answer you get. So 1, 2, 3. So in this way, I'm going clockwise, right? I would be an R, but because I switched it, it's going to be an S. So now would be a good time to pause and see if you can do these other ones, but I'm just going to keep going. In assigning priority, we have 1, 2, 3, and 4. I want the number 4 to be on the back right here. So I pretend that I switch them. I say, okay, this is going to be number 4, and that one therefore is 1. You always switch the 4 one with whatever's on the dash. And now we do our clocks. 1, 2, 3, like this. That's clockwise. You would want to write R, but it's actually an S because you've switched them. Keep them going. Bromine has a 1, chlorine's a 2, this methyl group's a 3, that's a 4. You want to get the 4 group on the dash, so I'm going to cross that out and write 4, cross that out and write 1. 1, 2, 3, go around that way. Right now we're going clockwise R, but we know it must be an S because we switched them. Last but not least, we're down here. This would be our 1. Here we have carbon and a carbon. But the thing is, this carbon has another carbon, so this is our 2, and this one's just a lonely carbon, number 3. And this would be our 4. Remember, if we have a dash here, we're going to switch with our low priority group. Now we've got 1 to 2 to 3, like this. So we're going in the, appears to be the S direction to me. But because we switched them, it's going to be an R. All right, so I hope that helps with R and S configuration, figuring it out. Have a good day. Bye.